to cover. If you have any questions, feel free to, I don't use Twitter too much, so you could do Dan at Brandcast. You could also do at Dan Patrick Lynch on Twitter. I will get the notification, and I will definitely respond. So whatever works best for you guys. So I'm going to talk about end-to-end JavaScript. And we're approaching 2015, so the end of 2014 will be the closing of the standards for HTML5. I thought we were going to get a hover car and a hoverboard. Instead, we got HTML5. That's OK, because the future's still looking pretty bright. Because we've got this thing called Node.js. So there's billions and billions of web pages out there running JavaScript. And now we can code that same language on the server, which is really great. And it's probably one of the most popular languages on our planet, if you can think about it that way. So HTML5, it's a standard, more or less. It's a markup language. But if you think about it, the standard is a little bit more than that, because if you look back on what our first standards were as a civilization, we started out with cave paintings and putting ideas into ideograms, and then eventually we're like, this is an alphabet, and here's how we can construct words and sentences. And then eventually we had written text, and then the printing press sort of helped democratize information so that people could buy their own books and learn themselves. And then, TCP/IP and the internet and all these great things happened. So I actually view HTML5 as encompassing much more than just being a standard. It's really a form of communication for all of society. So with that, myself and all of you, we have a pretty big responsibility to use our digital scribe in a way that pushes humanity forward. So just keep in mind that it's not just like we're coding apps. We're actually sort of using this communication medium that has really changed society, and it's really exciting to what will happen in the future. So to give you a little background about myself, I'm probably here because I built this web page in some circa 1996. If you need a designer, please let me know. So I had the web ring, web page awards, all that kind of good stuff. You've got the frames going on. I don't even remember what font that is, but anyway, so I used to skateboard and build web pages. I still do both things. Guess I never got bored. Then I kind of got into a lot of computer graphics stuff, procedural modeling of urban environments. Ended up sort of having an epiphany and going to college at UC Berkeley and doing a bunch of cool stuff with 3D graphics. This is a Vim interface to building 3D scenes. And then I built a company called Famous. Some of you might have heard about it. And then went back to school, did a project called Mathopedia, which is an ethnographic approach to software design where I just parse a typesetting language and make it into an interactive programming environment with JavaScript. And currently, working on a company called Brandcast. We are working to democratize web development and also, obviously, for non-technical people, but also catalyze web development for designers and developers. And our beta right now is sort of like an Adobe in the cloud. It sort of gives you a lot of tools to build websites with other people. So we have like a real-time collaborative editing experience, sort of like Google Docs, but for WYSIWYG website editing, and as well as a bunch of developer tools that we're using internally that eventually we'll probably have a few hackathons, and it's really cool. You can create all these cross-platform devices and things like that. But that was a quick brief on my background. I love to build tools for people. And the point of this talk is how to build tools for yourself so that you can express your ideas through technology much faster, more efficiently, etc. So how is coding related to user interface design? So design is this huge thing everyone's talking about and kind of focused on these days. So what is our user interface to our coding environments? And that's sort of what I would like to talk about, because we might be able to make something that looks really pretty, but if it's not pretty on the inside, that's really hard for us to express really amazing things, right? We're kind of fighting our own frameworks, or kind of wrestling with the code, even if it looks really pretty on the outside. So imagine what we could do if we had a really amazing environment. So if we think about where we've come in history, we used to use punch cards to do software. And we had numerical computing machines and all these different things. But at that time, did they think that this was not innovative? Because we look back on it now like it's archaic. So my question to you guys is, like, what are we doing today that in 20 years or 10 years we're going to look at and be like, "That I can't believe you guys were doing that. Like, you have to use your hands, or whatever." And a lot of times I feel like we're doing software construction instead of like engineering or art. And we're just kind of wiring up like paths or dealing with like all these issues that we're kind of fighting with our framework. So I'm challenging us how to think about building something that allows us to express ourselves more freely. Trip Hawkins, 1982, they at Electronic Arts released this post, and they came up with this idea of the software artist. And the idea is that the artist didn't really have to worry about the marketing and all these other things, and could really focus on building an immersive experience and focus on the software. And so what kind of experiences could we build that will allow the artist to express themselves? So consider Jimi Hendrix. Imagine if he had to plant a tree, harvest the wood, solder some circuit boards, create a recording studio before he could even write a song. How many albums do you think we would have experienced? Would we even be experienced? So the idea is, if we can minimize the distance between the intention, the ideas that we have, and the execution of those ideas that become in the form of an application, imagine the things that we could build, the ideas that we could express that could impact other people's lives. So this brings us to why code end-to-end JavaScript. While there's billions and billions of pages out there, JavaScript is probably one of the most popular languages on our planet. I also think that we all hear that to be an expert in something you need 10,000 hours. So if you're constantly switching between like Python and JavaScript, and then you're like, oh wait, now I don't use semicolons, and now my Vim configuration needs to have this white space thing, or whatnot. So you can become an expert faster. The community is amazing. The Node community especially is probably one of the fastest growing communities I've seen. And obviously not having to deal with context switching is really great. Although it's probably good for your brain to try new things. It's also good to become really good at something. So for example, you're not thinking about syntax, you're just thinking about the logic at that point. Because you're so immersed in the language that it's more about what it is you're building, less about how you're building it. So you can get more to that why and the what. There's a ton of other reasons that are not on this list. These are just a few that came to the top of my head. So, and also Node is, you have the power of C and C++. So it's not like you're using a toy here. This is like a very serious instrument that we get to use. So I'm going to give you a little sense of what we're talking about. Programming patterns, so MVC, facade, mediator, and the proxy pattern, and a few others that won't be explicit, but they're implicit in some of the programs. Bringing together the front end and the back end. We're actually going to see some examples of how to run your front end code on the back end and do a bit of code sharing there, which allows you to do some things that weren't previously possible. And we're going to talk about metaprogramming, which is have a definition here. So it's the writing of computer programs that write or manipulate other programs or themselves as their data or that do part of the work at compile time that would otherwise be done at runtime. In some cases, this allows programmers to minimize the number of lines of code to express a solution. Does anybody know where this picture comes from? All right, a couple people. Cool. So you should probably check out this book if you're getting into programming. It's called The Structure and Interpretation of Computer Programs, written by Abelson and Sussman. And that book was written to teach intro to learning computer programming at MIT and UC Berkeley using Lisp, or actually I think Scheme, which is a dialect of Lisp. In short, it's a very functional language that can do very amazing things with higher order functions and all sorts of stuff that you couldn't previously do in other languages very easily. So, and to that end, I think JavaScript is probably the most like Lisp of any other language I've seen. Obviously, it looks like C, but it has, and it behaves like things that you can do with Scheme. And I think Brendan Eich purposely, when he created JavaScript at Netscape, was thinking about giving it functional properties like Scheme while making it look like C. And here's a quote from that book. So thus, even though our programs are carefully handcrafted discrete collections of symbols, mosaics of interlocking functions, they continually evolve. We change them as our perception of the model deepens. So people change, so does software. So let's help people build things that are meant to evolve. And that's one of the things we're going to be talking about, is building a modular code base so that as your company changes, as your team changes, you can add and remove code and modules and refactor things, and the application as a whole should maintain functionality. Asynchronous control flow, because that's always an issue when people start coding in Node. APIs, and obviously the funnest part of building something is building something that somebody else can experience. But in order to do that, you have to make sure that it's ready for production. And so we'll be talking about building, packaging, deployment, and those kinds of things. So some various module definitions. There's so many modules, I'm just going to start digging in so that we can know what we're talking about. There's the JavaScript module pattern, which is basically just using closures to give you private and public encapsulation. I'm kind of breeze through these since my previous talks go into this stuff in detail. So please reference that if there's anything that you don't understand, or grab me afterwards and I can go into details there. So there's AMD modules. I'm mostly talking about these and just going to give you some different styles of using it. There's the Amd Array Style, where you have your define and then you have an array of strings. And what will happen is that the arguments to the function ends up being the libraries that you're specifying in that array. There's another way where you can actually not pass an array, you just pass in a function to the define, and the argument is require itself, and you can use more of an NPM style require inside of your AMD modules. This is better in my opinion. The reason being, if you use the array syntax and you have a ton of libraries, you really have a problem like matching which library maps to which function. So I would just say it's no bueno. I would not do that. I would just go like this. And just so you know, the RJS optimizer, which minifies your code and packages it for deployment, will pick this stuff up as long as the require call is not inside of an execution context that is sort of buried in your logic. If it's at like an outer layer, like an object, or in the parent scope, RJS optimizer will pick that up. And there's Browserify and NPM modules. I actually wish that AMD was like this, but you know, things happen. So this is another type of module that we'll be seeing on the back end, and some people are using it on the front end with tools like Browserify. So Nicholas Zakis was a front-end engineer, Yahoo. He's one of the leaders in large-scale front-end JavaScript application architecture. I'm going to breeze through a lot of his work here just to give a background of how we can build a large-scale JavaScript application architecture, and then how I've extended it to do some of the things like routing and layouts and rendering client-side code on the server, and all these sorts of interesting things here. So we have an application framework. You've got your core, which is at the base. This sort of abstracts your base libraries like jQuery and DOM manipulation, deferreds, those types of things. You've got your sandbox. This ultimately is the thing that exposes the functionality of the core to the modules. It's sort of like the contract or the agreement. So all the modules end up touching the sandbox and can get the functionality of the core because they all require the sandbox. Extensions directly modify the core. So you can make a layout extension, a data extension. You could make a routing extension, and then expose those functionalities to the modules through the sandbox. And that pattern is the facade pattern, so that the modules aren't actually directly touching it. And then the core also plays an important role with message passing to provide intermediary communication between the modules, so that the modules don't actually have to require each other. And we'll see that in a second. So here's an example of a really basic module. Here's an example of creating a view. So you always access the sandbox to create everything. Here's an example where you're creating a model. So obviously it's somewhat of a trivial example, but just to give you a sense, you kind of require the sandbox. You can create models, you can create views, whatever it might be. But for everything that you build, you're mostly requiring the sandbox is the first thing that you're going to do. Unless you're writing an extension, and then you would require the core. And we just mentioned extensions, so these modify the core. And the way that would work is you literally just require the core. You can directly add a property to it, and then you would end up writing the facade pattern that exposes that property in a way that so the modules can't actually modify directly the property. So here's an example of like a data extension, for example, that uses reflection to generate models based on a schema, which I will actually show you in real detail. So here is sort of the facade pattern illustrated a little bit, where the modules all touch the sandbox, but they don't actually touch the core. So the core actually has all the real functionality in it, which means that you can actually change the implementation however you want in the core. It doesn't matter, because the modules are always interacting with the sandbox. And so that actually makes refactoring really easy to do. Whereas if you just had one layer and you needed to do a refactor, you're going to have to change every single one of those modules. And so here's what the facade pattern looks like. Basically, you're just ending up calling the function on the core and using apply, passing the context in the arguments. And I'm going to breeze through this stuff because, as I mentioned earlier, a lot of this was in my previous talk, and more interesting new stuff is coming up. But the core has like two main things that it does. You can see these functions. There's the starting and stopping of modules, and the subscribing and unsubscribing and publishing. So it has sort of managing like the conduits and the channels of communication between all the modules, and it kind of starts and stops them and lets them register themselves with the application. So it acts as a communication hub, and that provides the mediator pattern. And what that does is if you know how the number of channels increases as you add communication layers, it's like n times n minus 1 over 2, which is like exponential, whereas this is always only n channels. So it's a constant factor, and you can continuously add new modules without increasing the complexity. So where to start? I would check out the Backbone boilerplate built by Tim Branyan. It has a lot of really cool stuff for the modules and the build system. I would check out Adi Osmani's Aura. That gets into like modules, widgets, and the message passing. And just to give you guys a sense of why this stuff is important, back to the communication thing. People think that as you add more engineers onto a project, you're going to be able to build it faster. But that's actually wrong. Because if you increase the number of communication channels, it's going to take you longer to finish that project. That same analogy applies to your code, right? So that's like spaghetti code, when you have all these things that have to know about each other, and it kind of becomes a mess. And in things like C++, it's really a mess. So unless it's perfectly partitionable, then obviously adding more people, it can finish your project very fast, because they don't have to worry about what each other are doing, and everything's very interdependent. And what ends up happening is you have modules that know nothing about the application. They just know what their job is, and the application becomes defined as the sum of all the modules working on their independent jobs. So that means that the application's working as long as each module is doing what it needs to do. And I'm only breezing through some of these because I think that in the interest of time, there's some things that are more code related. So you're going to want to decouple your code. And so things like URLs, routes, controllers, data, models, and collections, layouts, views, templates, we use these things all the time. So we want to be able to build those things very modularly and very quickly. So that's like a top-down approach would be like we have modules and extensions and plugins. But the bottom-up approach is that we know for every single website we build, we probably have routing, we probably have pages and data and APIs. So we need to abstract those things away, all the repetitive web development tasks, so that we can just focus on building things and obviously building them for extension. So getting into some of the cool stuff now. So front-end MVC rendering problems. Does anyone know what I'm talking about with this? So what happens is when you're using front-end MVCs, a lot of the time, you're serving a bunch of JavaScript to the client, and then the front-end MVC is like making a bunch of views and populating them dynamically on the front end. So if a robot were to crawl your website, this is what it sees, essentially, is nothing. And that's a problem for SEO. It's actually also a problem for performance. And so this is where we come to bringing together the front end and the back end. And the first thing, that font is not correct, so I apologize for that. Google font issue, I guess, with the internet here. So this is Meta, but you're going to want to require JS on the back end, and you're going to run the application after modifying some paths. So what you're going to do is normally you have your require JS configuration, and you have what I do is I actually put that in a module on the back end, and I generate my front end version of that so I can require those same paths on the back end. I'll show you what this looks like. And then you use require.js and you give it those paths, and then you can export that so that you can now require your front end code in your back end. And then a bunch of your libraries are going to, this is really, these fonts are hilarious. Let me just refresh this page. Okay, that is just too funny. So this is not the font that it's supposed to be. I would not use cursive to describe code, but we'll have to deal with it. So we're setting up our paths here. Let me just move this. Okay. So a bunch of libraries are going to use document, window, and navigator. And so that's going to be a problem if you're running that on your back end. Node is just going to like die or like crap out. It's not going to know how to handle these types of variables if they're not defined. So one method, and this is probably not the most efficient, it was just something that I wanted to try out and it actually worked. But if you use JS DOM, it's a very lightweight way to get document, window, and navigator that actually emulate the real like ECMAScript window, document, and navigators, so that you can use them to instantiate jQuery. So there is an NPM version of jQuery, so actually using that instead of the front-end version. So there's a small hack that I had to do there, where you delete in your paths object when you're defining your require.js object. You delete the jQuery path, and then you define it by using regular require, not the require.js, to then return the NPM version of jQuery that you instantiated with the window and document objects that you stole from JS DOM. And if you put everything as an Amd module, you should be able to require your front-end code inside of Node. The hardest part is really just kind of getting some of these global variables working. So you'll find that you'll understand why global variables are a problem as soon as you start putting front-end stuff on the back end, let me tell you. And if you're doing any AJAX calls, let's say you have certain files you need to get, HTML templates or whatnot, you're going to want to proxy your jQuery AJAX function on the back end. And this is actually very dangerous, but just to give you a sense, for example, what it does is it looks at the URL and just sees if that file exists, and it uses an fs read file sync. So it just reads the contents of that file and will resolve with the contents of that file. And what that will allow you to do is if you had any AJAX requests in your application, the backend can then actually get those files and perform whatever it needed to. But that's not going to work for your API. So let's talk a little bit about that. So people are probably used to building out models manually, something maybe like this, where you say, let's say you have a page model, has some sort of a URL. I'm actually talking about Backbone right now. So this is great. It works. But then I have to make a model every single time I have a new object on my back end. And then I have to go wire up the URL. And then I have to go in the back end. I have to define it in Mongoose or MySQL or whatever I'm using. So this is where we're getting into a little bit about metaprogramming. So in computer science, reflection is the ability of a computer program to examine and modify the structure and behavior, specifically the values, metadata, properties, and functions of a program at runtime. And type introspection is the ability for a program to examine the type or properties of an object at runtime. So what I would do is define a schema that I can share in the front end and the back end, and we just saw how we could do that. So I actually defined this code in the front end, because then my back end already has it, because we just required the front end app. And I parse through the schema, and I can generate models using Inflection.js, which is a sort of similar to Ruby's like active record naming scheme stuff, so that you can automatically generate your models and your collections dynamically, so that every time you want a new model, you're just going to edit your schema. And then if you do the same thing for whichever ORM you're using on the back end, you get the same thing for free. So all you do is edit the schema. You've got your Backbone models in the front end. You've got your back end ORM. And it's all just there, and it works without having to go and code those things. So here's an example of the front-end generated models. And here's an example of the back end. And I think here's where I can show you guys a demo. Cool. So what I'll do, actually. Hello? Cool. So, OK. So here we go. Can you guys see this a little bit? So I'll make a new model. I'm going to call it, actually, instead of a skateboard, I wanted a hoverboard. So I'm going to make one of those. And I'm going to make my fields. And I guess it'll have a brand. And it'll have a width. You know. OK, cool. And I did, hold on, I actually do pay for Sublime. I'm just too lazy to put in the product key. That's the actual truth. And I just don't mind hitting escape. OK, so if I need to pull out the product key, I can share that too, just because I'm a pretty honest guy. I'm from the Midwest. OK, so I got my hoverboard, and I can create a hoverboard. And so let's say it's, anyone know any skateboard brands that would make a hoverboard? Birdhouse. Well, Birdhouse is cool because Andrew Reynolds used to ride for Birdhouse, and that's my favorite skateboarder. I actually got the privilege to skate with him one time, which was awesome. OK, so this is a really quick, oh my God, did this not work? Hang on a second. OK, let me go back. Sorry, we'll make the hoverboard work. I guess I wasn't running supervisor. I was actually running the app. Normally I run supervisor so that when it looks at when my code changes, it'll restart the app for me. I happened to mess that part up. So Birdhouse, back to the Birdhouse. I normally skate in 8.5, create a new hoverboard, and boom. So that's actually in the database. It was created by creating a Backbone model, and on the front end, and then it sent it to the back end and created a mongoose object. But I actually just edited a schema. So I never actually had to go create and wire all this stuff up. I never had to go say what the API was, because the API was automatically generated for me. Because APIs are things that we've known about for years, why should we be manually creating these things? We should just be using RESTful theories to do that stuff for us so we can focus on things that we're passionate about. So let's go back to the demo, or the slides. So how does this work on the back end? I actually make a core function or property that lets me know if I'm on the server or the client, kind of Meteor-like. And I add a core.models. So we can change the backbone sync functions to if it's on the client, we just return the regular sync function. So this is sort of the proxy pattern, if you will, where you kind of store an original reference to a function, or you can override it. Actually, the backbone actually provides the easy way to do this kind of stuff. Anyways, so if it's on the back end, it'll go through, it won't return, and this here, I'm actually using MongoDB. That here is actually a MongoDB call in my front-end code in a backbone object. But I know that that's OK because on the front end, I know my core.isClient is going to return true. And so only that will be done in Node. And it's an easy way to kind of like run the code in 2 different places. So, but like all this meta stuff is cool, but if there's something specific that you know you want to do, how are you going to extend that? So that's actually really easy to do. You just make another module. You require the sandbox. Because there's a data extension that I wrote, which I probably glossed over, but all those models are getting generated and put onto a data object. So sandbox.data will have all of those models and collections, so that you can just require that and you can extend whatever properties you want. So let's say you want to make an initialize function. You can do that. And let's say for example, here I'm extending a collection, which is a collection of decks. This is actually the real code I'm using to present these slides. You know, it sorts them based on the order, so I can order my slides. So that's kind of fun. But there's a caveat. You need to include that model inside of the module that loads the deck, that does the routing stuff, which we're about to get into. So that does work there. So components, the new hot topic, web components, really awesome. Until they are everywhere, like how are we going to, you know, what's the bridge between now and then? So anatomy of a module. And I think this is actually probably very similar to how web components are going to work anyways. So you've got your CSS, your HTML, and your JavaScript. There is a main.js. Ignore that for now, but let's just focus on the component aspect, which is you've got your views, you've got your templates, and your styles. Templates are usually HTML and context. You've got stuff we all know about, Markdown. You've got variables and things you can do. Things about templates I want to point out. People use paths in their template names for Backbone. I think that's really bad, personally. I like to make hashes, and I'll override. I use Layout Manager, and I'll override the fetch template to a custom function depending on my workflow to grab the templates, because that way you can just literally like go into your code base and you can move folders around however you want, and you're never going to run into any weird problems. So paths, file paths are one of the worst things in computer science. So do everything you can to abstract them away. Use hashes and component names, and it kind of makes sense if you're building a component that like the component has some HTML, the component has some style. So just name those things accordingly, and it should be very logical and all that kind of stuff. Other thing about templates, when you're building your views and you're making some action, don't use classes to select stuff. I know it might be more efficient, but I promise you, if you're working on any large code base, your CSS developer and designer will remove those classes. And then all of a sudden your app will break. So This is bad. This is good, because they won't touch your data attributes, right? Because they can look at that and they're like, wait a minute, that must be a functional thing because it says like data dash action or data dash something. So this will save you a lot of times, unless you have a small team and you can do whatever you want. But just a suggestion, I've run into a lot of issues in the past where it's really good to have a convention. Really will help out. Also, CSS encapsulation. Another thing that web components are supposedly going to do for you, but why not drive a manual instead of an automatic? Just scope your modules yourself. Some of the CSS precompilers will help you do this by just sort of like scoping it. So that's really helpful there. And understanding the view lifecycle. So there's initialize, before render, after render. These are important things to understand. So it's sort of like a C++ object. You have your constructors and your destructors, except you have obviously these like new rendering functions. So what are these? Well, the before render, this comes from Backbone Layout Manager, which Tim Branyan writes, but I think it's a really good abstraction. So before render is before the object is rendered. After render, it should be in the DOM. So if you're going to do some jQuery thing, sometimes you can do it in before render. It really depends on the case, if you have like L set to false or not. So there are some details there that I would be careful about. But otherwise, it's really good to understand these view lifecycle functions, especially if you want to get into view mixins. So this is something that can really help dry your code. And if you're not familiar with what dry means, it means don't repeat yourself. So here's the code that I've used to highlight my code in these slides. So I'm using this highlight.js library, which is really awesome. And I'm looking through my code elements that live inside a pre-tag, and I call this function on them. And that's great, but I have a ton of different views that I was using, and I didn't really want to copy and paste this everywhere. And I didn't want to have to get into like weird like prototype, extend, and calling super functions. So you can use a view mixin. It's sort of like an underscore mixin, where literally you're just extending the prototype. So what that will do is if you can register functions like this after render function with like your sandbox plugins hash, then you can call it on a bunch of different views. Let me show you an example like this. So what I can do instead is I can make a completely new view with a different template or whatever I want, and I can just say use highlight. And so that's automatically going to proxy my after render function. If I already wrote an after render function, it will call the original one and write the new code in there. The proxy pattern is, here's a very trivial example where you basically save a reference to the original function, and then you set the original to a new version, you do something new, and then you can return the proxied version with the original arguments and make sure to set the context. And that is why JavaScript is awesome. So routing, how does this actually all work? So there's a routing extension. It modifies the core and allows you to have middleware on the front end and obviously the back end if you can do it on the front end. And lets the modules register routes so that you have one sort of global router and they register themselves when it loads. And the way that you're going to want to get that to work, if you understand the core lifecycle, I modified Adi Osmani's aura to sort of know about having a router and a layout, and then the other modules were sort of just like arbitrary. The reason is you want to load the router first without starting it so that everything else can register their routes with the router. So that's a really important small detail, but the router should be known by the core. And then that way when you start all the other modules, they're basically telling the router what the route is, and then the very last step is you start the router so that the backbone history can be instantiated. And then your module can look something like this. You require the sandbox, you require your view, and you register these routes and you can pass them. You can basically say, the blank route goes to render, so does home, and it actually returns a promise to render. So you also see the sandbox.layout. I'm really sorry about the noise here, the feedback. Okay, so this is an important thing. So I'm binding a route to a promise. And the reason that's important is because that's sort of how this whole backbone on the back end rendering thing will work. And just actually, maybe I can. So do you see this code here? It's all been rendered by the back end. But obviously, the way that Backbone works, if I start navigating, it's going to modify the DOM. So just to give you guys an actual picture of what's happening, the backend is actually rendering all that DOM and serving it up. So how can I get Backbone routing to work like Express? Like you have your request.params, and that gives you a really nice way for accessing properties based on the routes that you're defining. And I'm doing that basically in the router extension. What I do is sort of dynamically generate the router configuration by when the modules will register their route with the core. The core basically knows where the router is, so it can proxy all these calls to the router. But I basically use the same syntax. It's pretty simple. You just split based on those little, this doesn't do every regular expression like Express will. This is like a dumbed down version just to get this example working. But if you have parameters that have a colon in the front, that becomes a variable name. And this really cool underscore object function is sort of like the Python zip function that will take two arrays, combine them together, so it matches the property names with the values that came in. And that way your front end routes can work just like your Express back end routes, so that you're not thinking in two different worlds. You're thinking in the same way in both places. Okay, just looking at time here. So here's an example of this talk. I've got my slides/talk and my slides/talk/deck. And then I will have the talk and the deck variables when I call the deck function. So I can assume that those are there. And so typically on the back end, you've got middleware, and then you call the controller. However, on the front end, with Backbone, usually you're just saying this route maps this controller. So how can we do, I think I did something funny with the animation. Sorry about that. So for example, let's say I wanted to query a collection from the back end on the front end, even though the front end's on the back end, so it queries itself. But the deck here does this thing with promises and resolves, and then when it's done, it returns this sandbox render view. But that's really hard to read. And let's say I need to do this same type of behavior in a bunch of different places. That's just going to make the code really unreadable and all these kinds of things. So what if there was a world in which I could write something like this, where I say before deck, get the decks and get the deck. For example, let's say this just does that logic that was all buried in promises and all these things. And now it looks similar to the way you would describe routes in Ruby on Rails, where you have a little hash in the front or something like that. And then the bottom assumes all the data is there, right? Because you have this middleware that does that job for you of getting your data and getting the particular thing from that data that you wanted, so that you can just use the parameters and return the view that ends up being rendered. Okay, cool. So promises, callbacks are just calls. It's no problem. And the reason being, you can wrap these functions in a way that's agnostic to whether or not it's a promise or a callback, or just a call. So every function has a length if you just do .length. So if you see this cb.length, so I did make an assumption that basically the functions take a params object and are modifying that params object through the control flow. And if there's two, I'm assuming that the second argument is a next function. Again, this is a trivial example. Otherwise, if that's not the case, I check to see if when I call that function, it returns something, and if that something is a promise, then I will treat it like a promise. Otherwise, I just treat it like a normal function call. So now you can basically write a before function that has a very linear flow. You can be referencing modules inside of other parts of your code base and their methods. And it doesn't matter if they're just function calls, if they're promises, if they're callbacks. It's very simple and clean. And so then you can write code that looks like this. So it's very simple, it's very readable, it's very dry, and it doesn't have a bunch of feedback in the microphone like this one does. So let me, Okay, cool. So I think our time is pretty good too. We've got a few minutes. This is perfect. So obviously all this stuff is cool, but you need to make it so it runs really smoothly. And so you want to optimize code, you want to minimize the HTTP requests and all this kind of stuff. The RG optimizer is really good for that. And often a lot of these things will just minify everything into one ginormous, JavaScript file, which is fine. But what if you want, well, first of all, let me get to the point of like, how are you guys wiring up all these JavaScript files into your AMD projects? It really reminds me of like what they used to do with the telephone operators in the 50s, because like I'll add a file in my code base and then I'll have to go in this configuration file and add it in, and it's really, I should be focused on making some cool animation or getting some really important piece of data, but I'm just like wiring up file paths. It's like really not interesting. So it reminds me that like we're kind of doing something similar to like what compilers and linkers and relocation tables do, and I'm not going to go and talk about what this stuff is, but it's like hardcore computer science stuff that we should not be doing. So I think you should abstract this whole process. There are tools like Grunt, Bower, and Yeoman. They're very unopinionated, so I actually think that you should be opinionated, and you should design something particular to your workflow so that you can literally just drop files in your code base and they automatically get optimized and bundled into appropriate bundles. So if you want continuous deployment and atomic updates, you're not going to want to build your entire tech stack every single time you make an edit. You're probably going to, let's say you have like your application core and you just need to make a change in the photo gallery. So what if you could make an atomic update to just that gallery? And then there might be like 10 different JavaScript files or CSS files that rely on that particular piece of functionality, but you shouldn't have to redeploy your whole application. There's a couple projects that do this decently for AMD with Grunt. It's called Grunt Require.js Bundle, so there's a bundle property. And with this particular code base, I made it so that you have these little component JSON configuration files inside your front-end code that let the application know how it should zip these up. So just to give you a little visual reference, this slide deck that I'm showing you has all these files in it. And it's like, 40 some, maybe 20 files. So that's great. What if I wanted to zip this up into one, but then that kind of defeats the purpose of the atomic updates? So let's say I could say, well, there's like maybe 4 or 5 modules that are important. So I can actually zip this up into 4 or 5 different modules, and those get updated accordingly. And the way that you can do that is, what I did was I used metaprogramming, so I made handlebars templates that represent these configuration files. So the configuration files are actually dynamic, based on parsing the code base for these modified component JSON that have a little bit of metadata in them. And that way, all this stuff that we have to do, we don't have to think about it every single time. You just kind of drop your code in, the code base kind of reads it in like a vacuum and knows how to appropriately optimize it. Also, everything should be a node module, in my opinion. So when you're building stuff out, if you can require it and use it in a very modular way, building it as a node module is the first way that will really help you in that way of thinking. But the issue is, if you're working at a company that is not doing open source code, that's sometimes hard to do. So I would check out Sinopia, which is a really cool proxy to the NPM registry. So you don't actually have to mirror the CouchDB and do that entire song and dance if you just want to store some private node module. So I would encourage you to do that, because I do think it's good to be coding things as modules. So big point is, optimize your workflow. These abstractions may not apply to you guys, but just look at your team and take a bottom-up approach to like abstracting the things that you guys are constantly doing over and over and over, that if it was abstracted away, it's obviously going to be done in one and only one way, and then you could focus on other things. So otherwise, you're going to be playing this game of telephone, right? So like you're kind of, the message gets lost in translation, right? Like, have you ever played that game where you say something and then eventually by the time it gets through to the end, it's not the same message? So if we can just focus on like the end goal instead of all the in-between stuff, we can actually really, get some things done. And also like a change of basis. So if anyone ever studied linear algebra, there's this concept of a change of basis matrix. So look at your behavior. And if you can build functionality that matches your behavior and can add existing functionality to it, then that's like optimizing around your workflow. So for example, even though all this really fancy stuff that, for these slides, I actually coded the whole thing in Markdown because I didn't really want to work with HTML, even though I love HTML. But sometimes, you want to take a workflow and build around your workflow first. They call that an ethnographic approach to design. It's actually an academic thing you can check out. Really helps you minimize the distance between your ideas and executing your ideas, which is really awesome. And a lot of that work, Brett Victor was a great person to look out for. Donald Knuth. Christian Hellman, he's so awesome. His keynote at the HTML5 conference last time was like one of the most inspiring talks I've seen. I would encourage you to go onto YouTube and watch him speak. It's quite phenomenal. Nicholas Zakis, Adi Osmani, Tim Brandon, these guys are all great, and a lot of these ideas that I've combined have come from them. And so what we talked about, centralizing your data, keeping your code clean and dry, automating your workflow, building an application framework built to last. And I know that we all have our own lives and our own companies and our own teams and all this stuff. But I think that there's one thing that brings us all together. And I think that that is much more than just this conference. It's a movement. And I want to thank everybody for coming here today because it's just indication of how far the community is coming forward. And I encourage everyone to remember that HTML5, it's not just a coding language. It's a standard that represents where we've come as a society for transmitting information as humans. So, with that, I thank you and appreciate your time.